Welcome to a brief look at a recent paper. Once again, in COVID papers, we are going to look at the recent paper that has said, at least according to the media outlets, that the 6 feet or 2 meters, if you're not imperial, social distancing is unnecessary or inadequate. So according to Google Trend, there has been an increase in the search for social distancing and Massachusetts Institute of Technology, because a study from 2 researchers from the Massachusetts Institute of Technology, the MIT, recently published a guideline to limit indoor airborne transmission of COVID-19 has been widely reported by many media outlets. We've got headlines such as, a new MIT study casts doubt on the so-called 6-foot rule. We will still keep our distance from Boston.com, and doing this indoors won't keep you safe from COVID, new study says from Best Life. Also, importance of social distancing overstated, study says from Infection Control Today. Staying 6 feet apart indoors does almost nothing to stop the spread of COVID-19, MIT study finds from Yahoo News. MIT study challenges indoor social distancing, highlights inadequacy of 6-foot rule from foxnews.com. And did MIT study really challenge 6-foot social distancing for COVID-19 coronavirus? Here's what it said from Forbes. So this is actually the study. It's a research article published in the Proceedings of the National Academy of Sciences of the United States of America, published online on April 15th, 2021, and submitted by Martin Z. Bazant and John W. M. Bush. So first thing to note here is that this is not really a medical paper. The authors are from the Department of Chemical Engineering and from the Department of Mathematics. So this is very theoretical study more than an observation. You can see that it's very heavy on the mathematics side. There is a lot of functions dealing with three-dimensional geometry, flow, production rate, and not really any kind of observation on a group of patients and what was the outcome in this situation or in this situation. Does this mean it shouldn't be taken into account? Of course not, it should take part in the considerations. However, it means that we must be aware that the results in the real world may not mirror the calculations. It's possible there are unforeseen, not yet noticed elements in the equation. Pun not intended, in equation. So before we start talking about the paper, a disclaimer: even though I'm a physician, I'm prone to errors. The study may itself be wrong, so this is not medical advice. Please don't take any decision based on this information before first reading the study yourself and consulting with your physician in case you are not one. The first 2 key points here to notice about the study are, first, this is not an observational or an experimental study. This is a theoretical study that's aiming to calculate through geometry and mathematics the fluid dynamics of the spread of the viral particles. It may be wrong, it may be right. It would be way more accurate to make some kind of experimental or observational, for example, a cohort or case control study, and select a pool of patients that have either been closer than 2 feet to other people or that have not been closer than 2 feet with other people, and then compare between these 2 groups if one has had higher incidence rates of COVID infection than the other, thus verifying this theoretical study. The second key point to keep in mind about this study is that it's saying about social distancing and not masks. Of course, it takes masks into account in its calculations. However, even if it proves that social distancing is not necessary, that does not mean you shouldn't wear masks. In fact, the study itself shows that the activity and the fact that people are or are not wearing masks is more important than the distance between them. If you're going to be into closed quarters inside a small room with other people, even if the study is correct and you will be at risk regardless for COVID infection, you can still improve your chances by wearing a mask inside closed environments. So, to quote the study from the abstract, the authors put quite clearly, quote, "We here build on models of airborne disease transmission in order to derive an indoor safety guideline that would impose an upper bound on the cumulative exposure time, the product of the number of occupants and their time in an enclosed space. We demonstrate how this bound depends on the rates of ventilation and air filtration, dimensions of the room, breathing rate, respiratory activity, and face mask use of its occupants, and infectiousness of the respiratory aerosols." What does this mean? It means that depending on where you are or what exact activity you and the other people that are there with you are doing, social distancing may either be pointless or unnecessary. What it doesn't mean is that social distancing is never useful. It does not say that. This theoretical study proposed a method to evaluate the airborne transmission of COVID-19, that is, infection by the particles that are suspended in the air after someone exhaled them. What the study acknowledges but does not calculate is the risk of infection from droplets, which is massively higher if whoever is infected is not wearing a mask and closer than 6 feet or 2 meters to you. So if you're talking with someone that's not using a mask, it could still be a great idea to keep your social distance, not because you are worried that being close to this person will increase your risk of being infected through airborne contamination, but rather because being aware that your airborne risk of contamination is the same, you don't wish to further increase your risk of being contaminated by droplets. So what the study is not saying is that social distancing is never useful. And it says, right here at the end of the abstract, quote, "Particular consideration is given to respiratory jets, which may substantially elevate risk when face masks are not worn." End quote. Personally, I think the greatest potential takeaway from the study wouldn't be that the 6 feet rule is completely pointless, but rather that the 6 feet rule is not sufficient depending on the ventilation of a room and the activity that's being developed there. That is, social distancing is not enough to protect a large number of people in a single poorly ventilated room. And that conversely, social distancing may not even be necessary if we're dealing with an open, well-ventilated place. In fact, the paper is not named "The 6-foot rule is wrong." It's named "A guideline to limit indoor airborne transmission." To justify why airborne transmission in COVID-19 is more important than droplet transmission, the study cites a series of events where there was little or no correlation between infection and distance to the index case. That is, supposedly, if you sat 10 meters or 30 feet away from someone else that had COVID in a closed room and then contracted the disease yourself, you were infected through airborne transmission, that is, literally by viral particles that were exhaled by this person and literally kept floating in the room's air until you inhaled them. They explain the transmission in, quote, "When people cough, sneeze, sing, speak, or breathe, they expel an array of liquid droplets formed by the shear induced or capillary destabilization of the mucosal linings of the lung and respiratory tract, and saliva in the mouth. When the person is infectious, these droplets of sputum are potentially pathogen-bearing and represent the principal vector of disease transmission, end quote. They delve into deeper detail about what they mean in a closed, well-mixed room when they mention that, quote, RC equals equation, above which drops generally sediment out and below which they remain largely suspended within the room prior to removal by ventilation outflow. We here define airborne transmission as that associated with droplets with radius r smaller than rc. That is, airborne transmission is that caused by droplets that do not sediment spontaneously, rather persisting airborne, floating in the air of the room. Some of the major takeaways from this study can be synthesized by a paragraph of the study itself. Quote, to minimize risk of infection, one should avoid spending extended periods in highly populated areas. One is safer in rooms with large volume and high ventilation rates. One is at greater risk in rooms where people are exerting themselves in such a way to increase their respiration rate and pathogen output, for example, by exercising, singing, or shouting. Since the rate of inhalation of contagion depends on the volume flux of both the exhalation of the infected individual and the inhalation of the susceptible person, the risk of infection increases as Q²B. Likewise, masks worn by both infected and susceptible persons will reduce the risk of transmission. You can see, for example, in this table, that the authors of the study have estimated the amount of infective quanta based on different activities being performed in the room. According to this theoretical work, your risk of infection being close to someone who is speaking would be greater than someone who is not speaking, and will be greatest when someone is singing or shouting, for example. They also take into account the benefit provided by using masks. In quote, in both examples, the benefits of face masks is immediately apparent, since the CET limit is enhanced by a factor of PM squared to -2, the inverse square of the mask penetration factor. Standard surgical masks are characterized by PM equal to 1 to 5%, and so allow the CET, the cumulative exposure time, to be extended by 400 to 10,000 times. End quote. That is, given the same conditions, for example, the same room or the same vehicle, it will take at least 400-fold longer to be infected by COVID-19 when standing in that location if you were wearing a mask than if you weren't. They produce these graphs, for example, showing essentially the risk of being infected given how long you spend in a place versus how many people are there. Quite intuitively, the more people in a closed space, the higher the risk. The worse ventilated the place, the greater the risk. And the longer you spend there, the greater the risk. Even though they do not calculate the risk for droplet infection, they did take into account the risk for respiratory jets in the absence of masks. Quote, thus, in the absence of masks, respiratory jets may pose a substantially greater risk than the well-mixed ambient. End quote. That is, if people are not wearing masks, standing close to someone else while they breathe or speak, not keeping your distance, may indeed increase your risk for infection. It's also important to keep in mind, once again, that this was a mathematical theoretical study. There are a lot of inferred values in it, and there are no guarantees that it accurately and completely represents the real situation. It would be interesting to test it with large observational studies. That said, regarding the study message, we can cite one of the paragraphs from the discussion. Adherence to the 6-foot rule will limit large drop transmission, and adherence to our guideline would limit long-range airborne transmission. End quote. The way I personally see it is that perhaps 1. Social distancing guidelines could be ignored if people are wearing masks, and 2. The number of people in a room, the activity they are performing, and the length of time they will be spending there should be considered when determining the risk for SARS-CoV-2 transmission, rather than simply the distance between them.